We begin material from Chapter 3. In order to analyze a real-world signal, it is useful to come up with a mathematical model. Then we may predict some things about the signal by manipulating its mathematical model. This chapter deals with, so to speak, building block signals that can be combined to form an infinite variety of such models for real-world continuous time signals of interest. We are motivated by the property of linearity. A signal processing operation is linear if it satisfies two properties. The scaling property states, a linear operation performed on Cx gives the same result as C times the result of the operation performed on X, where C is a constant. For example, taking the time derivative of X is a linear operation. Therefore, we may conclude that the time derivative of Cx is the time derivative of x scaled by c, where c is a constant. The second property of linearity is the additive property. A linear function of a sum of terms is the same as a sum of functions of each term. That is to say, the operation distributes over a sum. For example, the log operation cannot be linear, because we know that log of x1 plus x2 is not equal to log of x1 plus log of x2. The scaling and additive properties may be combined into a single expression that is called the property of linear superposition. A linear function of a weighted sum is a weighted sum of the functions of each term. Clearly, linearity has a strict definition, and not every function is linear. Luckily, we may model real-world behavior to be approximately linear over some restricted range of operation. This gives us the benefit of being able to apply the rules of linearity to greatly simplify our analysis of the actual behavior. So, if we are able to model a real-world signal by combining various building block signal components, we should always try to combine these components as a weighted sum, ax1 plus bx2 plus cx3, etc., because, since operator f was chosen to be linear, the result of the operation will simplify to a f of x1 plus b f of x2 plus c f of x3, etc. Next, we will look at various signal building block components used to model continuous time signals.